order of operations. System of equations is basically just more than one equation at a time. Okay, so in Algebra 2, when you started these, you started with linear and you kind of branched out from there. I think, the very first time you ever solved them, you would look at the graphs. You would graph two lines, and when you were finding the solution, what were you looking for? Where they intersect. So if you're looking at a graph, you're looking for the point where they meet. We have different techniques for that, so we're going to look at a couple different options. First thing though, just a few things. You don't necessarily have to write this down. Whatever you don't know, make sure you put in your notes. So a solution just makes both equations true. If it has a solution, we call that consistent. And if it doesn't, there are two different types. There's consistent where the equations are independent, and there's consistent where the equations are dependent. Consistent means it has a solution. If they're independent, that means it's two different equations, so you have a unique solution. If we're talking about lines, it's just one answer. You have one place where the two lines meet. If I were talking about lines, how could we have infinite solutions? If they're the same line. If I give you two lines that are the same, so every point on that line makes them true. So if it's independent, they're two different lines. If it's dependent, it is the same line. And then anything that cannot be solved is called inconsistent. It's either substitution or elimination to solve these. Do those terms sound a little familiar? We're going to start with linear systems. Section 5.5 is actually doing the same thing with nonlinear, so I'm going to do both types today, linear and nonlinear. So, for example, here is a system. X plus y equals 8 and x minus y equals 4. If I asked you to solve this by substitution, then what we have to do is take one of the equations, solve for one of the variables, and substitute that into the other equation. So what do you want to solve for? X in which equation? The first or the second? I heard second first. It doesn't matter. You can do any of them. There's no right or wrong. So if I want to solve for x, to get that x by itself, I would just add my y over. So x is 4 plus y. Now you have to substitute that into the equation you have not used. So I haven't used this first equation yet. I will substitute it in there. So in place of the x, I'm going to put 4 plus y. Plus y equals 8. So I just replaced this x with my 4 plus y. Now we have an equation with one variable, so we can solve. 4 plus 2y equals 8. So 2y equals 4. And that means our y is 2. Am I done? No. We need to solve for both variables, so I have y. Then if I plug that back in here, I can get x. So x is 4 plus y, but my y is 2. So x equals 6. I would like for you to write your final answer as an ordered pair. So x comma y. If for some reason your variables weren't x and y, you just do alphabetical order. So if I said A and B, you just put A then B. And you can always check these. It has to make both equations true. So 6 plus 2 does equal 8. 6 minus 2 does equal 4. So we can double check our answer there. All right. Ready for yours? So solve that one by substitution. So y is 5 minus 2x. You plug that into second equation. So we have 4x plus 6 times 5 minus 2x equals -2. subtract over my 30. So x is positive 2. Then plug that back in to get your y. So y is 5 minus 2 times 2. So 5 minus 4, which is 1. So my answer is ordered pair 2, 1. You can always check it. 4 plus 1 is 5. Negative 8 plus 6 is negative 2. So it works. Are we good with substitution? So the other option is elimination. With elimination, we need to eliminate a variable. So what we want to do is add these equations together so that something cancels out. They cancel out when their coefficients are the same but opposite. So a positive 2 and a negative 2, positive 5 and a negative 5. A lot of times to get that, you will have to multiply at least one of the equations by something. So pick, do you want to cancel x or y? X. All right, so what could I turn them both into? Okay, this is a negative 4. I could get this one to be a positive 4. All we have to do is take it times 2. So that gives me a 4x plus 2y equals 10. And I did not change my second equation. If I had said I wanted to cancel out y, what would we have done? Multiply the top one by negative 6. Okay. So now if I add these two equations, positive 4x and negative 4x cancel. 2y plus 6y is 8y equals 22. Divide by 8, and that would reduce to 11 over 4. As far as fractions or decimals, I don't care as long as you're not rounding. So 11 over 4, that's 2.75, that would be fine, but 1/3 is 0.3 repeating. I don't want you to just round that to 0.3. So in that case, you would need to keep the fraction. So your answers have to be exact. You're all grown up now, so everything doesn't have to be a nice, pretty number. Don't be surprised if you get some fractions or decimals. Doesn't mean you did it wrong. Once I have my y, how do I get my x? Does it matter which equation? No. So pick one. If I just go with the top, 2x plus y, which is 11 over 4, equals 5. So subtract that over. 5 is like 20 over 4. Minus 11 over 4 is 9 over 4. Divide by 2 and we get 9 over 8, or 1.125. So then final answer, we write them as an order pair. So all of these systems so far have been consistent, independent systems. They were all two different lines. They did meet. We were able to get a solution. So far, so good? Let's look at this one. What do you want to eliminate? The y? Okay, so how do I do that? Top times negative 2. So that gives me negative 4x minus 2y equals negative 10. So when I add these together, negative 4x and positive 4x cancel. Negative 2y and positive 2y cancel. So we have 0 equals negative 2. Is that possible? So what do we say? No solution. I do also want, anytime you have a no solution, what kind of system is it? Inconsistent. So on these, anytime you get a no solution, I want you to put both parts. Put the no solution and then go ahead and say inconsistent. Alright. Let's do at least one more like these. so let's do this one. And I didn't say whether you had to do substitution or elimination on this one, so you could do either. What would you do? You did substitution, and that would work. Did anybody do elimination?
Yes.
So substitution, you just solve one of them for one of the variables. Elimination, what would you multiply by?
18 was up.
Okay. If you're not sure, you could always just divide. Like, what is -6 divided by 1/3? 18. So that's where the 18 comes from if you can't figure out what you need. So let's go ahead and try that. So 1/3 times 18 is 6. 18 times 1/6 would be 3. 18 times 2/3 is 12. When I add these together, both my x's and y's cancel, so I get 0 equals 0. What does that tell me? They are the same line, so it's infinite solutions. Now, here's the difference. Up until now, you've always just been able to say there are infinite solutions and move on. But when we do these, your directions are going to say to, in this scenario, to write it with either x arbitrary or y arbitrary. Okay, here's the deal. When I say infinite solutions, does that mean any ordered pair I pick out of the blue has to work here?
No.
No, it's just any point on that line. So we have to describe that somehow. So if I said to write the solutions with, let's say, y arbitrary. If it says that, that means keep y as your variable. So my ordered pair will be something for my x, and my y will just be as a y. So how would I find that thing for my x? You could just think about substitution to solve one of these equations for x. So if I want to do that, if I solve this one for x, I could add over my 3y. If I divide everything by -6, -12 divided by -6 is 2. 3 divided by -6 is -1/2 y. So I can't just say infinite solutions. You have to somehow tell me what those solutions look like. If I had said write it with x arbitrary, what would that mean? You keep the x and you have to solve for y to figure out what to put there. Okay, so that is the piece that's slightly different, just how we have to handle it in that scenario where our system is dependent. Do we need to do another one like that? Is there okay with it? Can I do some nonlinear ones then? Make sure we know how to handle that. So our techniques are the same. You're still going to do either substitution or elimination. A lot of times we may have to use a combination of the two. Essentially here, we almost have 3 variables. We have the x, we have the y, but we also have x squared in here. What do you think we should eliminate? Let's get rid of the y, since at least the x and the x squared are the same variable. So I could easily do that here. This is already set up for my elimination to work if I just add these. Negative y and positive y cancel. I can't add x squared plus x, so I just have to keep that. 4 plus -2 is 2. So then what should we do?
Or subtract.
Subtract over the 2. And this is a quadratic, so we can factor. approximately. So x squared breaks into x, what multiplies to -2 and adds to +1. So we get x equals -2 and +1. Okay, with the lines, we were only getting one solution, but when they're nonlinear, you can get more than one. This top graph is a parabola, the second one was a line, so a parabola and a line could meet in two different places, and that's what we found here. So we're going to have two different order pairs. I have my x, I have to find the y that goes with each of them. So to do that, we just plug it into one of the equations, doesn't matter which one, so let's say I went with the second one. So that means x plus y equals -2. And when I put in -2, I get out 0. Okay, if I put in 1 plus y equals -2. So then I get y to be -3. Again, you can always check these. -2 squared is 4, minus 0 is 4. 1 squared is 1, minus negative, so +3 is 4. It works for both equations. So with the nonlinear, it is possible to get multiple answers. Don't be surprised when that happens. All right. So far, so good? I'd like to try a couple more like that, and then I am done. You guys think you could do this one? I think you can. Let's try. What'd you do first? Okay. We really have two variables. We have x squared and we have y squared. So we could either do substitution or elimination. Probably easiest if you just add these together. It's already set up. Elimination works great. 1x squared plus 2x squared is 3x squared. Positive y squared and negative y squared cancel. 4 plus 8 is 12. Divide that 3. How do you get rid of a square? If you add a square, what else do you have to have? So x is positive and -2. So we have two answers again. Alright, so to get y, we just plug that into either one. If I go with the top one, when my x is 2, 2 squared is 4. So y squared equals 0. Square root and your y is 0. What happens when you plug in -2? Same thing. -2 squared is still 4. And again, you get y equals 0. So positive 2, 0 and -2, 0 are both answers. We can also have ugly answers. We could have imaginaries because we know how to deal with all that stuff at this point. So my last problem for today, I want to solve this system. So what would we need to do? You could do substitution or elimination, either way. So if you wanted to eliminate x, you would take the top one times -4. If you want to eliminate y, you take the first one times -3. If you want to substitute, we'd probably solve the first equation for one of them. So any of those options will work. What do you want me to do? Okay. So let's say I want to eliminate y. Let's just take those times -3. Didn't change the second one. Also, guys, it may work out where sometimes you have to multiply both equations by something. I didn't have that come up on any of my problems, but let's say if you had a 2x and a 3x and you wanted to cancel those, what would you have to do? Multiply the top one by 3 and the bottom one by 2. So you can change both of them if you need to. Alright. So negative 3x squared and positive 4x squared is 1x squared. Negative 15 plus 11 is negative 4. You need square root plus and minus. And what is the square root of negative 4? So, we have two solutions so far, positive 2i and negative 2i. So if I plug those in, if I put in 2i squared is what? Negative 4. So then we would have to add over the 4. And then to get rid of a square, you need square root plus and minus. So we actually get two answers, positive and negative 3. So if my x is 2i, I get positive 3, but I could also have 2i comma negative 3. So we might get more than two answers. What's going to happen if I plug in negative 2i? Same thing. So we get a total of 4 answers here. All right. Questions on that? So that is actually all I have for you today. There is a handout with 8 questions